So this is a circuit we just built, and we set a function generator output 100 Hz, 20 volts, peak to peak, a sinusoidal wave to the circuit's input. Then we use two monitors of the oscilloscope to monitor the first channel, to monitor the voltage across the resistor, and use the second channel of the oscilloscope to measure the voltage of the input. So you see, I did some adjustment to make both curves, both the green and the yellow curves, occupy as much as we can on the screen of the oscilloscope, which will improve the precision when we output the data into the MATLAB, which we showed in the previous lab. So now the peak to peak voltage for the yellow curve, it's 1.1 volts. 1.1 volts per division, and the reading peak to peak is 8.4 volts, and the green curve, which is the input from the function generator, so it's peak to peak 20 volts, 21, 22 volts, 20.1, 20.2 volts. So there's slightly so we set it to 20 volts, but slightly off a little bit because of precision and resolution of the function generator and the oscilloscope. So there's a 0.1 volts difference, and the second channel is 2.6 volts per division. So they show similar magnitude on the screen, but they do have different peak-to-peak voltages because the scale is different. For the yellow one, it's 1.1 volts per division. For the yellow one, it's 2.6 volts per division. So let's take a closer look on the numbers on the oscilloscope. So the scale for the yellow curve is 1.1 volts per division. So the yellow curve is the voltage across the resistor. And the peak to peak of the yellow curve is 8.4 volts. For the scale for the green curve, it's 2.6 volts per division, and the peak to peak is 20.1 volts. The green curve is the input from the function generator. So in the next step, we try to tune the frequency of this sinusoidal wave of the input of the RC circuit to make the voltage across the resistor is half of the voltage of the input. So now the input voltage is 20 volts. So we want to make the yellow curve to be 8 volts. So now it's 8.5 volts. So comparing to the previous picture, I increased the yellow curve scale a little bit, so you see it zoomed a little bit, get depressed a little bit, but still it shows the same peak to peak value, 8.5 for 100 Hz. So now let me increase the frequency to make it to be 10 volts. $105, 106, 107, 107 Hz. Now it's 8.96 volts. So yeah, we want to be 10 volts. 108. So 120 Hz now, and we get 9.8 volts. Still, we have a little bit to go. A little more to go. 122. So now we have 125 volt, 125 Hz for the input frequency of the sinusoidal wave, and we get the voltage across the resistor, the peak to peak become 10 volts. It's exactly half of the input, which is the green curve, 20 volts. So remember the number 125 Hz. We need this number in the data analysis part of this lab report. So let's take a closer look at the function generator, 125 Hz. You see the numbers on the top, 125 Hz. So let's take a closer look on the oscilloscope. So the voltage across the resistor, the yellow curve, it's 10 volts peak to peak. The green curve is the input from the function generator. The peak to peak is 20 volts. So before I go to the next step to output the oscilloscope data into the MATLAB, let me tune the yellow curve to be zoom in a little bit to occupy as much as we can on the screen to make a high precision for the output data. We press it to get a linear function, right? So then we increase a little bit. So the next step, we're going to output the data into the MATLAB.